It's a big one. When we use line geometry to control the tool path, it's both controlling diameter and length. We're going to make some modifications for this line geometry to provide the result we want. When we actually go and part this thing off, we're going to want to do the chamfer plus part it off in the same operation with parting tool. Right now, if we zoom in, because this part is 1.725 and the bar is 1.75, there would be extra material here and here if I didn't continue the turning tool past a little bit, right? So we're going to modify these lines to make sure that happens. We're going to go wireframe, trim. We're going to trim this entity by clicking it to this entity. Okay, so it just extended that line until this line. Anybody want to do that right quick? We'll go trim. We'll click this line, we'll say trim to that line. Yep. Cool. Now the next one we want to do, there's going to be a slot back here for the parting tool. So I'm actually going to extend this line by how wide the parting tool is at least. Okay? The parting tools out there are about 160 thou. I'm going to give it just a little extra and I'm going to extend that line by 200 thou. If I go modify length, I can say lengthen by a metered amount, so 0.2. Modify length, 0.2. Whichever end of the line I click is where that will be applied, so I'll click closer to this end and get this. The last thing, if this was a large shoulder, like say the diameter of the bar was much larger than 1.75, using a line toolpath right now, it wouldn't know that when I go to rough it. It would only see the diameter expressed by here. So to do this accurately, I actually need a little bit of tail. I'll draw this here like it's a shoulder. I'm going to draw a line here to represent the middle. And I go transform, offset, 1.75 divided by 2. So the radius of the bar. Okay, and I get this. Okay, the reason I'm doing that is I'm going to trim, offset. This, that way. I'm going to go wireframe and trim this part. Okay, I can delete this, and I can delete that. Okay, so I have a line that is the same diameter as the part. It goes a little bit past where it is, and then provides a shoulder. And the reason it's doing that is it's roughing the bar off for the parting tool to come in. Okay? After my line geometry looks like that, I have a very simple tool path to control this, the majority of this operation. If I go turning and rough, we're going to explore a couple of utilities inside this. We'll work up to finish and some interesting strategies in another lesson, but today we'll be able to do this whole thing with rough. If I select rough, it's asking me for a chain. I would recommend selecting this avenue. It's called partial. So it's not looking for giant loops or connected chains. It's going to allow me to select the first entity of the chain and the last entity of the chain and connect it to it. So if I select partial, my first entity is going to be this one, and my last entity is going to be this one. Okay, so it now knows that that profile is in fact what I'm looking to turn. Because I already set this tool up with the correct rad, with the correct number, double checking always, we're going to reuse it. Okay, the feed rate, and you may want to write these down. For your first part, let's go about 8 thou per revolution when roughing. Let's do this at about 400 surface feet per minute, and let's not go faster, okay, than about 3,000 RPM. So constant surface speed being enabled means as the tool moves in on the diameter, this lathe is going to speed up so that it's engaging the material at the same speed. Okay? When the lathe rotates, the diameter you're working with makes one rotation. Say it was 2 inches. We know pi times diameter is the circumference. So one rotation of a 2-inch circle would be 3 times 2, about 6 inches around, right? As soon as you go to a 1-inch bar, now it's only 3 inches around. So to engage the tool at the same speed, the lathe has to go twice as fast. Okay, so with constant surface speed being enabled, as the tool moves towards x0, the lathe will increase in RPM. My comment here becomes important. I'm going to say rough and finish. Okay, this is a strategy we're going to get away from in lathe 2 and 3, but for this one we're going to use rough and finish in the same entity. After that, I'm going to start going through my roughing parameters. I would like to take a depth of cut of no more than about 30 thou. That one is important. You'll notice before I did that, it said 0.1. That is like 3 times too much. Okay, it's not that an industrial lathe can't do that, it's the tool posts on those bosses is reasonably light duty and you don't want to overflex it. And you'll start to see weird things happen, the tool will move around a bit, you can turn the post, you can break stuff. Let's keep it conservative for the first one, we'll say 30 thou of depth, and a minimum cut depth of about half of that. So rough this out with 30 thou cuts, and don't take cuts smaller than 15 thou. We're also going to say leave some material in X. So when you're done roughing, leave 10 thou in X. Also, leave some material in Z. One thing that we'll explore is tool pressure. There'll be more explanation about this inside lathe 2. Right now, I'd like the Z to be half as much as the X. So we'll leave 10 thou in X, we'll leave 5 thou on all of the shoulders in Z. The last thing we're going to do, well actually let's uncomplicate this. So if I leave that, so all I've done is rough this at this point. If I was to back plot this, we'll see the tool come in and take 30 thou passes and rough it at the profile. When it's done, if I zoom in, I'll be able to see it never actually got the diameter, right? It left 10 thou. And it also never got the shoulders. It left 5 thou with those 2 meter inputs. The last thing we're going to do is now use this toolpath to also finish those. If I go back into it, and I check this box, semi-finish. Okay, it's saying take 1 pass along the entire profile at the end, and once I access this menu, if I still want to leave material on for another tool, I can do that. The other thing I can do is adjust the feed and speed. Okay, so roughing, I might be wanting to feed very quickly to get the material off. Finishing, I probably want to go a little bit slower so that it looks nicer. Okay, so what I'm going to do is go feed rate. I'm going to ensure this is in inches per revolution, and where we were roughing at 6, I'm going to finish at 4. Okay, so each time the lathe makes 1 rotation, the tool post is going to move over 4/1000ths of an inch. As a general rule, the radius on your tool strongly impacts the surface finish related to the feed. If I have a 15 thou rad, so a very small one, and I feed it very fast, it will look like a thread. Okay, a really almost pointy insert moving too quickly across the material, and it'll effectively look like a thread. If that was a giant radius, you know, and my cusps were smaller, I could move that quicker and have a better surface finish. Because it's a small rad, we're going to go reasonably small for the finish rate. Now that I've done that, if I click green check mark again, we're going to see the addition of 1 toolpath. So we still have the same thing as before, we're roughing this.